In this video, I will explain you the variation of impedance. Now we know an Lcr circuit, a series circuit where L, C and R, these three elements are connected in series. And this is the impedance triangle where this is XL minus XC, this one is R, and here the angle is phi, and this one is hypotenuse is impedance, and the value is root of XL minus XC the whole square plus R square. And this is the value of XL, L omega, and XC 1 by C omega. So I have just substituted the value of XL and XC as L omega and 1 by C omega respectively, and I got a value, an equation in this way. Now variation or change of L and C and R would not be present in a circuit because R, L and C would be constant when they are connected in this way. Okay. Anyway, resistance of a resistor will not change unless there is a change in temperature or change in dimension, or it is made with a different material. Here also inductor. For an inductor, its value of L would be constant. For a capacitor, its value of C would be constant. So variation of C would not be due to L, C and R. Then it would be due to what? It would be due to this omega. And change of omega is possible when we are changing the frequency of the input or the power supply. So power supply is E is equal to Em sin omega t. Now whenever frequency is different, then the value of L omega minus 1 by C omega would be different. Or basically I can say that whenever frequency changes, XL will change and XC will change, and making the change in the net value of the impedance. Now let's say when initially we will see what is the minimum value possible for an impedance. So this is square of a value plus square of another value. Okay. Anyway, R will not change. We know that, right? Only the thing is XL minus XC will change. Now this is a positive quantity after squaring, and this would also be a positive quantity. Now this is square root of sum of two positive quantity. Now the minimum value of this would be when this is equal to 0. All other cases, whatever may be the value of XC minus XL minus XC, either it is positive or negative, square will become positive. So if this is R square, even 0.1 additional to the R square will increase the total value of impedance. So to get the lowest value of impedance, this value should be 0. Value of R cannot be 0 unless we remove resistance R from the circuit. Okay. So the lowest Z possible when this quantity, that is XL minus XC, is equal to 0. That is the lowest value, and that point represent the maximum value of current, because we know that I is equal to IM is equal to VM divided by Z. So the maximum value of current is Vm divided by Z, and that will occur when the value of Z is the least. So least value of Z is possible when XC minus XL is 0, or XL minus XC is equal to 0. This value, when it becomes 0, this would be 0 plus R square, and at that value Z is equal to root of R square or R. So maximum value of current possible in an Lcr circuit. What is that value? Value is equal to I is equal to Im divided by Z minimum. So Vm divided by minimum value of Z, and minimum value of Z is nothing but R. So Vm by R would be the maximum value of current. And at that value Z should be minimum, and condition for Z minimum is equal to XC minus XL minus XC or XC minus XL. XL minus XC is equal to 0, which is XL is equal to XC. Now what is XL? L omega. What is XC? 1 by C omega. take omega here, so that will be omega into omega, omega square is equal to 1 by LC, or omega is equal to, implies omega is equal to 1 by root LC. See, now this represent that when we are choosing a value of omega as 1 by root LC here, okay, so I will substitute the value, omega is equal to 1 by root LC in this equation. So Z is equal to root of L into omega is 1 by root LC minus 1 by C into omega is 1 by root LC, and square of this plus R square. Now L and root L will cancel, and this will be root L on the top, root L. Now C and root C will cancel, and this would be root C here. Okay, now I will have root L divided by C minus root L divided by C, the whole square plus R square. So root L divided by C minus root L divided by C is equal to 0, and square of that would be 0 plus R square, and this would be R. Okay, so this is very important. So one thing is for sure, that is when frequency is equal to 1 by root LC, Z gives the minimum value, and which means opposition to the current would be the least. Z means reactance, and that represents opposition to the current, and that would be least in the LCR circuit and giving the maximum value of current. Now when frequency, three conditions we are going to check. Three conditions. Condition 1, this is called as natural frequency of the circuit, where frequency become 1 by root LC. At that position, current will become maximum. So I am going to represent omega as omega 0, natural frequency. Now our omega, when it is greater than omega 0 and omega less than omega 0, we will see. Now when this omega is greater than omega 0, so this value would be great, and this value, when omega increases, this would be less, and the total value, this will decrease and this will increase. So higher value minus lower value square would be a higher value plus R square. So I can say in this condition, when omega is greater than omega 0, then impedance increases. Check here, substitute omega here, L omega will increase, and when omega increases, denominator increase will be a total value decrease. A higher value minus lower value square would be a higher value plus R square. Now when omega is less than omega 0, this one is very important. So this value is decreasing, but see, now omega's value decrease. When this value decreases, this value would be high. Okay, now this value will be high, this value will be low, but it doesn't make no difference. In the first case, when omega decreases, this increased. So let's say that the value is 5, and this decreased, and the total, when omega increased, this total value increased, that is 5. When omega, this one increased, this decreased, and this increased, and the total value decreased. So let's say that value is 2. So 5 minus 2, the whole square would be the initial value. Okay, for example. Now in the next case, when omega decreases, see, L omega it is, right? This will decrease. Say for example that become 2, and omega decreases, denominator decreases, and the whole value increases. Let's say that become 5. Now this whole square. So 5 minus 2, the whole square is 3 square, 9, and 2 minus 5 is minus 3 the whole square, and that will also be 9. So what is the inference from that? In that case also Z increases. Now if the value of omega, so in an axis I am going to represent omega 0 here. Now all the value of frequency which is greater than omega 0, impedance will increase. Now all the value of omega frequency which is less than omega 0 also, the value of impedance will increase. So on the both the side, impedance will increase. Now if impedance is increasing, what will happen to the current? We know current is equal to Vm divided by Z. So when Z increases, current decreases. Now if I am plotting it on a graph, see, I have an xy axis. Let's say this is omega 0. Now at omega 0, natural frequency omega 0 is equal to 1 by root LC, and at that position my Z is equal to R. Z is equal to R, and that would be the maximum value of current possible. Now to the right side of omega 0, frequency omega is greater than omega 0, but there also impedance would be higher. Now when impedance Im is equal to Vm divided by Z, when impedance is higher, current decreases. So this is the maximum value of current decreases here. Now to the leftwards of omega 0, when omega 0 decreases also, we have seen that impedance will increase. So when impedance increases, current decreases. See, this is called as a resonance curve. The maximum value of current will occur when value of omega is equal to omega 0, that is the natural frequency 1 by root LC. To the right hand side, current decreases, impedance increases. Here impedance increases, current decreases. Value of impedance would be lowest here, and to the either side of this, the value of impedance will increase. But we won't be drawing the graph for impedance. Generally we would be doing it only for the current, and this is the maximum value of current. Now in the coming video I will explain you how to tune a circuit, and we will learn more about this graph. Okay, thank you.